Sven Schleier to his talk, Intercepting Mobile App Network Traffic, aka the Squirrel in the Middle. Thank you.
Working? Now it's working. Okay. Hello, everybody, and thanks for joining my talk today. You already heard the title, Intercepting Mobile App Network Traffic, aka the Squirrel in the Middle. So just briefly about myself. So my name is Sven. I've already did quite a few things in the last few years, but mainly was doing a lot of penetration tests and was working as a consultant. And at the moment, I'm the technical director of F-Secure in sunny Singapore and was just flying in over the weekend. And I'm also one of the project leaders of the OWASP Mobile Security Testing Guide and the OWASP Mobile AppSec Verification Standard, a horrible long word. But this is what I'm mainly working on in my free time also in the last few years. And occasionally I'm also blogging, but that's happening unfortunately not that often. But one thing that I did do earlier this year that I published on my blog was just a decision tree in order to cover different kind of edge cases when you're doing a mobile app network testing. The thing is, many times when I was doing mobile app testing, there are some different edge cases and challenges that you might need to tackle. And it was just a lot of different situations I came across during pen tests that were a bit tricky. And I simply wanted to share how I solved them, or also how I heard it from others, how they solved it, and summarize everything and share with others, just to have a proper methodology like this, and that you can follow this decision tree in order to tackle all the problems. So we will not be going through everything in detail here. I prepared now a few demos just to guide you through. And yeah, so we just start with this. And I will be covering mainly iOS today, simply because there's usually a lot of information for Android out there, but iOS is usually not that well covered, I would say. So we're focusing mainly on iOS and all the different things that we might be able to intercept. So the usual setup when you do testing is of course very similar when you do a web app test. First of all, you need to of course configure, in this case, your iOS device. You need to set your proxy to your interception proxy, like for example Burp Suite. And once you have done this, you should be able to capture all the HTTP traffic, of course. If you want to intercept the HTTPS traffic, obviously we need to get the Certificate Authority, complicated word, into your iOS device. Once you have done this, your iOS device has the CA in the trust store, and obviously it will then accept also the certificates that are being generated from Burp Suite, and everything is good and happy hacking. At the end of the day, this is working, of course, for some of the iOS devices, but what I will be covering and going with you today is through all the edge cases where this setup might not be working. So there are different scenarios, and I'm grouping them now into 3 different scenarios that we will be going through today. And the first one is you might not be able or not allowed to connect to a Wi-Fi with your rooted or jailbroken device. So this is one scenario. Some apps are ignoring the system proxy. So even though that you have set the system proxy, the app simply doesn't care and is still sending the HTTP requests out, and you might not be able to see them in your Burp Suite. And the third case is that some apps are simply relying on non-HTTP protocols. And as we know, Burp can only encode or decode HTTP. But some apps are relying on XMPP, even on raw TCP. And of course, we still need to figure out a way of how we can intercept those. So now let's go through it one by one. And you can see this very little squirrel in the background that is happily nibbling on a phone. So this is just the result of a conversation that I had with my 8-year-old daughter when I tried to explain to her what a man-in-the-middle attack is. In order to make it a bit more attractive to her, as she's very much into squirrels, it became the squirrel in the middle. And I think she finally got the point about it. So for this talk, we will stick to the term squirrel in the middle, and we will follow the squirrel on the journey on how to intercept network traffic of mobile apps. So the usual setup for your mobile pen test will be very similar to this. So you have your iOS device, you have your Wi-Fi access point, and in order to become your squirrel in the middle, you will be redirecting the traffic to it. So as they are on the same Wi-Fi network, it's usually very easy. The thing is just, I had several occasions in the past where the setup wasn't working for me, because when you go on-site to clients, especially very big clients, then there might be some limiting factors. One of it was that I was not allowed to connect my jailbroken iOS device into the Wi-Fi network. It's jailbroken, the security controls are of course disabled. There might be malware on it. There's of course a lot of malicious software running on it that was installed via Cydia. So you're violating the policy and you cannot use the device in the client Wi-Fi. Okay. Another thing is there might be client isolation, meaning even though that your phone and your laptop that you might be using is in the same Wi-Fi network, they might not be able to talk to each other, simply because the laptop and your iOS device are isolated from each other in the Wi-Fi, and they might only be able to communicate to the access point and have internet access, but the communication itself might be blocked between the clients and the Wi-Fi. And last but not least, this happened to me actually twice, that the client Wi-Fi was full, so I was not able to connect anymore. This is rarely, but it actually happened to me 2 times. And so I still could connect with my MacBook, but there was no space left for my iOS device. So there might be different cases that you might need to tackle. The question is just, what can we do now to intercept the traffic of an iOS device in the Wi-Fi network without connecting an iOS device to your Wi-Fi? What we can do is we can test via secure shell tunnel. So first you would connect your iOS device via USB to your laptop. Then we can use iProxy. iProxy is basically a SOX proxy that someone developed already many years ago, in order to do tethering with an iPhone, but we can use it also to use the secure shell server on our jailbroken device in order to forward the ports here. So I'm just saying port 4x2 is my local port on my Mac, and it's being forwarded then to the port 22, which is the secure shell server on my iOS device. The next thing is, on my Mac, I do a remote port forwarding, secure shell -R, and we're using port 8080 to forward the port from our Mac then to the iOS device, and this will allow us then that Burp with port 8080 is then available on localhost on the iOS device. The rest of the setup is then pretty easy. We just go into the settings, we configure the proxy this time as localhost and port 8080. And the nice thing is now that we can literally connect now to any Wi-Fi. I just need to do this setting, because all the traffic will then be going now through localhost, through my USB cable to my Mac, and I'm able to intercept all the traffic, all the HTTP traffic that is going through the proxy. So this is, for example, on one of my iPads. You can see I'm here on localhost, and I can see now the Burp Suite landing page and can then install the CA certificate. So this is a demo that I prepared. So on the left side, you can see on the top left, you can see that I'm starting iProxy. And on the right side, you can see my jailbroken iOS device. And on the left bottom, you can see that I'm executing now secure shell. I do the remote port forwarding for port 8080 from Burp from my Mac to my iOS device through port 4x2, which is the iProxy connection that we're having. So now you can see I logged in. I go here to localhost now, port 8080, and I can see the Burp Suite landing page, meaning I can route now all my traffic through this. I know it's an edge case, but to be honest, it did save my ass a few times in order to make the testing actually possible because of some restrictions from clients, and this is a quite nice and convenient way. Okay, then let's come to the next topic, and this is the system proxy is ignored. So nowadays, I mean, we have, of course, iOS apps, Android apps. They are being produced through the usual tool chain, meaning for iOS it's then Xcode and Swift and Objective-C is programming language. Then we have on Android, we have Android Studio, where a developer can use Java and Kotlin, and with the Android toolchain produce the native binaries. But nowadays we have a zoo of various different frameworks that are also being able to produce native binaries. The benefit of these frameworks is that you just have one code base instead of two code bases to produce then iOS and Android apps. So one quite popular one at the moment is from Google, the so-called Flutter, where you're using the Dart programming language. Also React Native from Facebook, where you would be using JavaScript as your main language. And there's also Xamarin, which I think is not so popular these days anymore, but Xamarin from Microsoft, where you will be using C#. Why I'm mentioning this is that if you are testing or pen testing one of these mobile apps, not all of them would be using the system proxy. So even though that you're setting the proxy, and when you're testing, for example, a Flutter app, the Flutter app simply doesn't care about the setting. It will simply just send the HTTP request. And even though that you might be able to intercept the request from Safari, meaning your proxy settings are actually working, this will have no effect on a Google Flutter app, because it just sends out the request and bypassing the proxy that is being set. And the same applies to Xamarin also. So let me show you this here in the video. So you can see here on the left side there's my Burp Suite, and on the right side there's my jailbroken phone. And you can see that I was setting the proxy, which is the external IP address of my MacBook and the Wi-Fi. And I'm just going to example.com, and I can see the request in Burp. Everything is working fine. We can see here the user agent that it's actually coming from my iPhone device. So here you can see now a demo app that I created in Flutter. That is a very simple app. It just does two things. It has a blue button for an HTTP request, an orange button for an HTTPS request. And when you look at it, you can see that I'm pressing the button, but nothing is happening, even though that's an HTTP request. So now we want to test the app. Actually, everything is working, but Google Flutter simply doesn't care, and we are not able to intercept the HTTP request. So Flutter and Xamarin, we would need to take a different approach. And the question is now, of course, what can we do now? There are, of course, various ways now in order to intercept also in this scenario. One possible solution is the good old R poisoning that we could do, a layer 2 attack with betacap or etacap. Also DNS spoofing is a quite nice way. There is a Burp extension available called No Proxy that allows you to spin up your own DNS server, and then and then it's possible for you to intercept all DNS requests, all the HTTP requests that are based on DNS. So both works then, of course, on jailbroken and non-jailbroken devices, because you are tempering or want to modify the traffic, the network traffic that is going out of the iOS device. And this would, of course, also work for Android devices, meaning for Google Flutter apps that are running on Android. So this Nope Burp plugin is quite interesting because it's extending your Burp Suite with two new features. One is a configurable DNS server, which I will be showing you in a minute, and the other one is a non-HTTP man-in-the-middle interception proxy, which I will also be showing you later in another demo. So if we look now at this, what we want to do is we're doing now DNS spoofing via Burp. And then we will be able to see the traffic also that is coming from a Google Flutter app in order to become the squirrel in the middle again. So this is again a video to showcase this. So here are now the proxy settings. And my listener is also working, which you can see here. So when I'm just refreshing now my Safari, you can see that the requests are coming in, so everything is working. But we already know that this approach will not be working for Google Flutter app. So what we will be doing now is So as you can see here, it's not working. Neither the HTTP nor the HTTPS requests will be shown in Burp now. So we need to have a different approach, and this is where we can rely on the no proxy plugin. So you can see here, I'm using my external IP from my MacBook, and I just press this very big button, and then the DNS server is starting on this IP address. And the next thing that we should be doing is we simply get rid now of our proxy settings and get rid of the proxy, I mean. So we set the proxy to off, and we configure DNS instead. So we're just deleting all the entries that might be in there. Then we are setting the DNS to our DNS server that we were just running here, which is .1.100. Now we do this again. Sorry, one thing we need to do first. We need to add for port 80 and 443 2 new listeners that are also invisible, or so-called invisible. Just because it's not a proper proxy request, but the HTTP request, so we need to be in invisible mode for these listeners. And you can see it's working now. So when we do the HTTP request now, you can see that the example.com is coming, and the HTTP request is this JSON placeholder, this dummy request that is coming. And we are able now to intercept also a Google Flutter app via DNS spoofing. So this is one viable option of how you can, I would say, very elegant also intercept the HTTP calls of such mobile apps. So other possible solutions, if you have a jailbroken device, because this approach would obviously also work on a non-jailbroken device, because you just need to set the DNS server. If you have a jailbroken device handy, then you can simply configure also the etc hosts and put in the IP address and the domain that you want to intercept. IP address meaning that would be the DNS server that you have started. And otherwise, you could also set up an access point. This we have also described in great detail in the mobile security testing guide. And to summarize, I mean, there are various different things that you can do: R poisoning, DNS spoofing that I've just shown to you, modifying the etc hosts, an access point, all of different kind of difficulty, and maybe also preferences from the tester. But as always, there is a variety of things that one can do. This is, of course, not a complete list. There can still be things like you can set up your own VPN server. Some prefer even that. So there's a variety of things that can be done in order to tackle this problem. So now we have intercepted HTTP traffic from apps that are bypassing the system proxy. The next thing is, what can we do to intercept traffic that is non-HTTP? So again, if you set up everything correctly, you will see all HTTP requests, but you might still not see all the traffic because it might not always be HTTP. And this can have several reasons. So for example, XMPP might be used if there's any chat function available. Different ports might also be used. The thing is, even if you would be able to have the correct port, Burp would not be able, and also OWASP-ZAP, which is another open source interception proxy, they will not show you the traffic because they're not capable of decoding the protocol, because they simply do not understand it. So therefore, we need now to find a way of how we can make this visual and being able for us to intercept the traffic, even if it's non-HTTP. Before we can actually do that, we first would need to understand what protocols, what ports, and so what protocols are actually spoken, to which port is the app actually communicating with, and for this we would need to monitor the traffic first as a whole from the iOS device. So iOS doesn't let you record a packet trace directly, but you can use on macOS, you can record the network traffic by using a so-called remote virtual interface, or RVI, and this is very similar to a network tab, and that will mirror all the network packets from your iOS device then to your Mac, and becomes then a virtual interface on your Mac. The prerequisite for this is just that you're connecting your iPhone via USB to your Mac. You would need to identify the so-called UDID, the universal identifier of your iOS device. And once you have this, you can use the command rvictl-s, then the UDID, and then a new network interface will be created, which is then in this case called RVI0. And then you can just use Wireshark or whatever your preferred network sniffer is on this interface, and you will see all the traffic. So just to show you this here also, on the left side you can see I'm querying now for the UDID of the iOS device that is connected to my MacBook. Video is already a bit older, as you can see here, it's iOS 12.4. But on the right side you can see my jailbroken iOS device, and RVICTL is very simple, there are just a few flags. The only thing that we need now is -s, RVICTL-s and the UDID. After a few seconds, the remote virtual interface will be created. Now we can just execute, okay, now I'm just checking that the interface is there. Then we were just executing Wireshark with -i with the new interface. Wireshark is starting immediately, and we can see all the network traffic that is being generated on the iOS device. So meaning really everything now. So therefore it's important that you filter, because otherwise you're simply being overwhelmed with all the network packets that are flying in. So you can see on the right side, I'm just going to example.com, and there are now all the network packets, the TLS packets that are flying in, and I can see this now in my Wireshark. So this is very much needed if you really have no idea what protocol the app is speaking, because with this you can see actually what protocols are being spoken, which port the app is communicating to, and all of this information is then needed in order to plan your next steps. So you can also do this with Android, because on Android you also might need sometimes to understand what kind of protocols and what kind of communication is actually happening. So therefore you can also do remote sniffing on Android with TCP dump, netcut, and Wireshark. This allows you then to do everything in real time. So the first thing you need to do is you need to run TCP dump on the Android device. And in this case, we are piping then the output that is from TCP dump written to std out. We're piping it through netcut so that the output of TCP dump is now available on this port. The next thing we do is on my Mac, I do the so-called ADB command. This is a command that is part of the Android SDK already that allows developers also to do easily port forwarding or install apps or uninstall apps. And in this scenario, we're just using the ADB forward in order to forward this port that we just opened to my MacBook. And then again, I'm opening Wireshark, but with netcut. So I'm just connecting now with netcut to the port that I opened here on Android. And now I get all the output from TCP dump on my Mac directly into Wireshark. So this is a really neat way in order to get the real-time traffic, because otherwise you might need to do the TCP dump on your Android phone, then you need to copy the PCAP file, need to open that again in Wireshark, and this is very convenient in order to get all the traffic then in real time. We also have a more detailed explanation in the mobile security testing guide for this also, but basically this is the gist of it. So to show you again in a demo how it's working, you can see here I do an ADB shell, so this is an emulator running, and I start now TCP dump and pipe the output to this port. I do the ADB forward, so I'm forwarding this port from the emulator now to my MacBook, and I'm connecting via netcat now to this port and pipe all the output through Wireshark. Wireshark is opening, and I see now all the traffic that is happening on my Android device. So whatever I'm doing now on my Android device, whatever's happening in terms of the network traffic will be shown up here now in my Wireshark. So a few tips in terms of using with Wireshark. Of course, close all the apps in the background simply to reduce the noise that is then happening. That should not be happening, so you can actually focus on the packets from your app that you're testing. Afterwards, it should be pretty easy to identify then the IP address that the app is communicating with. Wireshark is, of course, a very mature tool, so please take advantage of the so-called display filters. Like, for example, once you identify the IP, you can use ip.addr and then the IP address to filter only for the network packets that you're interested in. Follow TCP stream in order to really get all the network packets that are related to your communication. And once you have done this, it should be very easy for you to answer the two questions: which protocols are being used, and also, is the traffic encrypted or not? If it's not encrypted, you can read it already here in Wireshark. If it's encrypted and if it's with TLS, then of course this would be another hoop that you need to jump through, but at least you know then what protocol is being spoken and what needs to be done. So to come back to this, how we can now become the squirrel in the middle for non-HTTP traffic, we again start our DNS server with the node proxy. We configure the DNS server. We add a listener for the port that we want to mirror. Sorry, I think I forgot just one thing. So here I was also identifying the port that I will be using later with Wireshark, because here we could identify that the app is also talking to port 31337 that I will be using here in the next demo. So all of these things we can identify then with Wireshark. Sorry, it's actually here. So here you can see the proof that it's working. Now I'm starting an application that I created. So this is an iOS app that is sending a TCP request to a TCP server. And when I'm pressing the request to button, you can see on the left that there are some TCP requests. Here's of course SYN, ACK, the TCP handshake, and then there is the TCP request that is being sent by the app to a TCP server. And you can see here the destination port is 31337. So this is the port where we would need to open another listener in order to get this traffic also into our burp, because it's not using port 80 or 443. So now we have all the information that we need. Yes, okay, so we see it's working. And one other feature that the node proxy is giving to us is the DNS history. So because the DNS server is running there, if I click on this button, you can see that here the DNS name is also showing up. And with the port that we got earlier from Wireshark, we have now all the information that we need, because we just need to put in here now the DNS name, the port name, and then we can create a new listener in Burp. So we are adding it, we enable this listener. So now our Burp is opening port 31337. And in this node proxy plugin, we have TCP intercept, which is like the Burp intercept, but this is then just for TCP or non-HTTP protocols. And when I click this button now, you can see that I'm able to intercept even the TCP traffic. So here's just some dummy credentials that were being sent. And I have now the capability to intercept also all traffic that is being produced by the app that might not be HTTP. So this is, I could see this also in apps that are really relying also on performance, for example. That might be ride-hailing apps, for example, that are simply want to avoid all the overhead of HTTP and are therefore using things like TCP and are relying on raw TCP. So to summarize the interception of non-HTTP traffic, we can use RVICTL as long as we have a Mac in order to monitor all the network requests that are happening on an iOS device. TCP dump can of course help us to analyze the traffic on an Android device. And with tools like Wireshark that are very powerful, we obviously can very easily identify then the right port, IP address, and whatever we might need. And the NOPE extension is a very powerful tool that we can use for these kind of activities. So the key takeaways for today are intercepting network communication has many edge cases. So we were going through a few today. The node proxy is a quite easy to use extension that you can use in order to test even for non-HTTP protocols. And the monitoring the network traffic is actually the very first step in order to plan your ways of how you can intercept the network traffic. So there are, of course, a lot of things that we didn't cover today. There's only so much that we can do in one talk. So I put in here a few more links because another topic or challenge that you might be facing in Flutter apps is if SSL pinning is being used in Flutter apps. So if you're a bit more familiar with bypassing SSL pinning in mobile apps, there are a lot of different Frida scripts available in order to bypass SSL pinning. The thing is just for Flutter, a Flutter app has their own trust store. So therefore it's a bit more tricky to bypass the SSL pinning. But there's a quite good and detailed blog post that you can see here from Visio. And they were describing in great technical detail of how you can find the right instructions and in order to tweak an existing Frida script that they've made available to also bypass SSL pinning in Google Flutter apps. And they also published a quite nice checklist for proxying Android app traffic that covers really a lot of edge cases that one might have or errors that one might be running into. Yes, otherwise, for those that are not so much into decision trees, my daughter and my wife also created a nice game out of it. So if you want to play the squirrel in the middle, you can download it in my blog. And otherwise, I just want to say thank you for your attention. And I hope you could learn something new today.
Okay, thank you. Are there any questions from your side?
I hope not everybody is now brain fried.
Are there any good equivalents for the tools used that are open source or available on BSD or Linux?
So the thing is, if you want to go with iOS testing, then it's really the best to have a Mac because all of the tooling, like the RVICTL that I shared earlier, that's only available for Mac. There is GitHub, there's a repo available on GitHub that is also trying to implement RVICTL on Linux, but it's unfortunately out of date. So therefore, I think it's only working with iOS 12 or 13. But otherwise, I would say the basic tooling for intercepting is Burp, the Swiss Army knife, anyway, for web app and mobile testing. Sorry?
I was mainly asking about RVI anyway.
Okay, gotcha. Okay, so therefore there's this Linux clone of it, and but it's unfortunately very outdated.
Okay, anyone else? Okay, then thank you.
Thank you.
Again. Until 4 p.m. I think.